This is a demonstration of power draw of household appliances for National 5 Physics. So what we've got here is a little power meter. It's currently measuring voltage. You'll be taught that in the UK the voltage is 230 volts, but that's always the case. As you can see here, we're only reading 217 today. You can also measure the current, currently reading 0, and power, currently reading 0. Hopefully you can figure that out, because there's nothing plugged into it yet. You can also see the frequency of the electricity, 49.8 Hz. So the first device we're going to plug in is a blender, and headphone users, watch out, because I'm going to turn it on, and we'll see what current it's drawing. So nearly an amp and around 124 watts there at the peak. Let's go for something a little less deafening for the second one, a kettle. Reading 1732 watts and drawing 8.14 amps. Next is a desk lamp with a common incandescent bulb in it. Reading 49 watts and drawing 0.22 amps. Next is the same style of desk lamp, except this time I've replaced the bulb with an LED one. So now we're drawing 9 watts and only drawing 0.07 amps. You might be beginning to see a bit of a trend here, so I can demonstrate that. I can even touch this bulb. What does that tell me about it compared to a normal bulb, which I absolutely wouldn't touch? Next I've got this fan heater, which I'll turn on to full. And it's drawing 1580 watts. And, oh, that's warm. 7.5 amps. I can also reduce it to half power. As you see, the current is roughly about half, and it's drawing 830 watts. I can even turn the heating elements off entirely. There you go, 26 watts just to drive the fan motor. So you can tell where all the other power is going when you turn on the heating elements. And 0.16 amps for just the fan. Finally, we've got a laptop charger, charging a laptop. As you can see, this is only 19 watts and drawing 0.16 amps. So hopefully you're beginning to figure out that items that don't produce much heat, such as a laptop charger, a blender, or just a fan, consume far less power than something that does produce heat, like an electric fan heater, an incandescent bulb, or a kettle. For the kettle and the heater, obviously the job of those is to actually heat something up, but in the case of the incandescent bulb, any heat loss from there is just inefficiency. That's why we're moving away from them and towards LED bulbs. As you saw in this experiment, the LED bulb had a far lower power draw, but for about the same amount of brightness. The only downside being they're slightly more expensive to manufacture.